Hi, Honors Algebra 2 students. Mr. Duranko here, giving you the third video in section section 6.1 on graphing exponential functions. The topic today is these two equations, which will express exponential growth and decay, and these are used quite often, especially with things like population. And the A in these equations stand for the amount that is present initially. The R stands for the rate of increase or decrease, and that's usually given in some percentage. So watch carefully in my example. I'll show you how to handle that. But if something grows, for instance, at 10%, then what you would put in here, we would pick the growth equation, and 10% R would be 0.1. So the decimal equivalent of a percentage. And T would be the time that we're letting that grow. And the units for that would be in the rate of increase or decrease number. So I'll give you an example showing increase, and then I'll let you try some problems on your own. So let's say that Zoom is very popular right now. So let's say that Zoom currently has 100,000 users. And let's say that in the month of April, the users increase by 2% per day. With this pandemic going on, everybody's Zooming everybody else, right? So Zoom starts out with 100,000 customers. Users, let's just say it, are growing at 2% a day. How many users will Zoom have in 30 days? So we take this equation, A of t, the initial number of users is 100,000. And since it's growing by 2% per day, we put in here 0.02, and we want to find out how much that number is after 30 days. So this is 2% per day, so this would be days, and it's asking for 30 days, so we'd put 30 in there. So we would put in our calculator 1.02 raised to the 30th power, and then multiply it by 100,000, and that answer gives us 181,136 users. So these exponential functions are very useful when it comes to finding numbers when we're dealing with percent growth over a certain amount of time. So let me give you a couple of these to try on your own. This particular example was a growth equation, but I'll give you some decay equations as well, and or decay problems as well, and we'll see how you do on those. If you have any questions, don't hesitate to email me back. Bye-bye. Have a good day.